All right, here we go. So integration. If I find the integral of 4x, all right, the first thing I have to remember, or let's just say I want to find the integral of x to the power of 1. What I have to do is take the power plus 1. All right, so that's going to become x1 plus 1. Then divide by whatever answer you get there. Divide by 1 plus 1. And we're going to add some constant c over here. So this is going to become x squared over 2. So what are we doing here? We're adding 1 and then we're dividing by that answer, which is actually the reverse of differentiation. Because if I had f of x equals to x squared over 2, which is half x squared, then when I derive this function, what I'm going to do is I'm going to take the 2 and multiply it by half and then minus 1. That's going to become x. So that's correct. So what we notice is that when we're deriving, we go from f to f dash, and when we go backwards, we integrate. All right, deriving goes this way, integration goes backwards. Let's have a look at some examples of integration. Let's suppose I've got integral of 2x, integral of x squared, integral of x cubed, integral of x to the power 4, integral of 8x cubed plus x squared. For this one here, when you have a constant, you can remove the constant outside of the bracket and just integrate the inside. And for each of these, we're integrating with respect to x, right? So I'm just going to put .dx at the end. When I integrate this one, it's going to become 2, and this is going to become x to the power of 1 plus 1, which is squared, and then divide it by the same power, plus some constant c. I can multiply the 2 in, and I'll end up with x squared plus 2c. And I don't even know what that is. That could just simply be another constant. Let's call it c2 or p or d. It's just a constant, just an extra number that we add on top to complete it. The integral of x squared is going to give me x cubed over 3 plus c. This is going to be x4 over 4 plus c. So we plus 1 divided by plus 1 divided by plus 1 divided by. That's going to become x5 over 5 plus c. For this one, we can integrate each part separately by distributing the integration into the question. And this is the 8, remember, can be removed. So I can just integrate the x component of the expression. That's going to be x4 over 4 and 8 in front, plus over here, we've got the integral of x squared, which is going to be plus x cubed over 3 plus c. And we can just combine all the c's together. This would then simplify 8 divided 4 twice, so 2x to the power 4 plus x cubed over 3, which stays as is. And then the two constants could become one big constant. Just keep it as c there. Okay, we've done the reverse for each of those bits. Now integration is basically the area underneath the graph. So if I have my y-axis and I have my x-axis and I have a starting point now, let's say A, and an ending point B, then what we call this is a definite integral. Let's suppose this graph here is y is equal to x cubed. Let's say 3x cubed plus 2x squared plus x plus 4. I want to find out, so the question will say, what is the area under the graph, and this is definite integrals. So we've seen the previous one where we just simply use the reverse power rule. This is now going to be definite. What is the area under this graph? Here we use a definite integral and we integrate 3x cubed plus 2x squared plus x plus 4 dot dx from a to b. Now let's say a equals -3 and b equals 3. So this will be -3, this will equal 3. Now that is going to become, if I take 3 out, I'll get 3x to the power of 4 over 4, right, plus 1 divided by x, and the number stays the same, plus 2x cubed over 3, plus x, 1 plus 1 divided by 1 plus 1, which will be x squared over 2, plus 4x, and now we do not put c for this one here. We do not put c here. We put brackets and we put our beginning point and our end point over here. And that's going to become 3 substituted in here, which is going to be 3 times 3 to the power 4, plus 2 times 3 to the power 3, plus 3 squared, plus 4 times 3, and this first fraction divided by 4, divided by 3, divided by 2. All right? For each of those. And then once I've substituted 3, as you can see, into each term, like that, I then subtract. I subtract -3 substituted into each term. That'll become 3 times -3 to the power 4 over 4 plus 2 times -3 to the power 3 over 3 plus -3 squared over 2 plus 4 times -3, all in a bracket. So this is now my actual area that I need to calculate. So what is this area? The area underneath the graph is the integral of the graph from starting to the ending point of the graph. Let's put this on a calculator. I'm going to call it A. And let's see if I can get this amount carefully on a calculator first. All right, so we got 95.25 from this component over here. And then we got 35.25 from this over here. So when I subtract it, I get 60. So this area is 60 units squared. Done.